Well, we'll get the internet fixed up down there.
All right.
Agoric's having a webinar right now as well, so we may be a little light on. Yeah, so I mean, for the benefit of future folks watching recording, we could probably get started.
Oh, sorry, I was saying Agoric's having a bunch of webinars today, I think.
Oh, nice.
I've seen them
There's a
tweet about it, yeah. I think that a lot of this kind of cross-chain stuff and IBC related things. Anyone want to try out the relayer?
Yeah, so me and Justin merged our changes on Friday, which was a big merge, which basically took all day. But yeah, so those changes were on my side. I went in and basically simplified and removed some possible vulnerabilities from the Ethereum Oracle. And the Ethereum Oracle is what is how the validators bring Ethereum state onto Cosmos. And they basically have to vote on events that come in from Ethereum. Each validator submits a transaction which says, I saw this. And then once you have enough of them, they, they're considered a real event and some kind of state change happens. So for instance, if someone deposits coins into the Ethereum contract, you would mint coins for them. And so that's what the Ethereum Oracle does. It tells the Cosmos chain that this happens so that the coins can be minted. So that was pretty much what I did last week. And Justin, what were your changes again? Sorry.
My changes were prep work for batches. So the orchestrator can now retrieve batches from the chain. Oh, okay. So for context here, Jahan was cleaning up some of the prototype work for like oracles, and that was tied into the prototype work for storing validator set updates. And there's also prototype work for storing transaction batches. So I got the orchestrator caught up with the prototype work in the chain, in the Cosmos module, such that the orchestrator can retrieve the transaction batches that it makes, send transactions that would go into transaction batches, sign the transaction batches, submit the transaction batches back up to the Cosmos chain, and this is where things stop working. So our goal is to finish out this process end to end such that we can take the signatures from the Cosmos chain, which are correct. We have Jahan also added some code to verify that the signatures were right when submitted to Cosmos. I think it was 2 weeks ago. Then we can finally submit them to our to the Ethereum contract and have two-way communication. So this is sort of what we are trying to do this week and what we want to do before we hit Broken Net 2, Testnet 1, whatever you want to call it. And that is that we need back and forth token transfers from Cosmos to Ethereum and Ethereum to Cosmos. And we need to be running on Stargate. So Jack, how this is going to interact with you is that your goal is to get everything, is to get the module compiling onto Stargate. Then Zaki and I are going to tackle upgrading the orchestrator, and then Jahan and I are going to tackle trying to rebase our changes to get batches working on top of the Stargate changes, which is going to be a little bit of merge hell. But unfortunately, that's what happens when we both need to work in the same modules.
Well, I think maybe the best way to do this might be because I think this Stargate upgrade is going to take 3 or 4 days. When do you guys anticipate having that batches stuff in?
We pretty much need to start tweaking stuff today. I mean, that's kind of the goal. We could probably shift it a few days in either direction. Like, I could just jump right into working on Stargate transaction compatibility. Um,
Well, if you guys get the batches stuff merged before the Stargate stuff is done, then I can
rebase
do
on
it.
that.
Yeah,
Okay.
might be easier to do it that way.
Okay. Well, either way, I think somebody's going to have to deal with a little bit of rebase hell, and we're all just going to have to get together and make sure that it works.
Yeah, and that's fine. That transaction code is likely going to change substantially.
Mhm.
So we'll just have to see how it goes. Is it mainly batching on the Ethereum side or the Cosmos side that's more difficult?
Uh, Batching on the Ethereum side is difficult, but it is done. Batching on what we need work to be done on the Cosmos side is management of all of it because the Cosmos module stores signatures, manages signatures, creates batches, but the Cosmos module creates batches and then it creates a data structure that says like here is your batch with your transaction in it. The actual signature and the signature verification and the execution of it is mostly on the Ethereum side, but there's a significant number of changes to be made, wouldn't you say, Jahan, in order to get
Yeah,
batches to
I'm
actually
not.
work right?
Well, I'm not sure. What I haven't since you were working on last week. I'm not sure what still needs to be done. But just to recap how it all works. Basically, on the Ethereum side, well, in terms of batches, batches are only going from Cosmos to Ethereum. So there's no batches from Ethereum to Cosmos. Well, I mean, the Ethereum side does communicate with the Cosmos side about batches that came from Cosmos. But what I mean is that transactions coming from where somebody's sending coins from Ethereum to Cosmos, those transactions are not batched.
They're
But
cheap.
when somebody's well, it's because you have a lot more control on the Cosmos side, so the validators can just be aware of what's happening on Ethereum. You don't need it's cheaper on Cosmos. You're right. So when you're sending coins from Cosmos to Ethereum, though, those transactions are batched and they're all put into Ethereum at once. And then what happens is that each Cosmos gives each batch a nonce, and in the order that it makes them. And so then those batches are prepared, and then relayers can take those batches over to Ethereum, and then
Right?
yeah. So the orchestrator code, it does two things kind of. One is and this is another one of these little small things we need to do, but one of the things it does is something I would call like ETH signer, which is basically just sign stuff for validators, but it's specifically just run by validators, and it's Ethereum keys that are registered on the chain. It's belonging to validators. But then there's also a relayer role, and the reason I'm calling it out separately is because anybody could relay stuff, right? It's like a regular relayer.
Yeah. Do we want to? Is there a plan to kind of separate those two pieces?
So
I mean, I would
Go ahead.
like to have the terminology be clear and stuff. I don't really have too much of an opinion about how we organize the code. But yeah, there's two different sort of roles.
Yeah,
Okay,
so the issue is that the orchestrator is a combined relayer ETH signer. It's two things in the same binary. That's all. Um, and there's some question like, should you maybe run a relayer as a separate binary? Um, at least for like the test net, it's obviously a lot easier to coordinate everybody running one binary. So there's definite infrastructure advantages. There's also disadvantages in terms of confusion, like what is the orchestrator? And the orchestrator is just a relayer and an ETH signer glued together. That's all it is.
Okay. This is really helpful context. Just based on the way that you're kind of talking about these changes, Jahan, on the SDK side, the 040 stuff shouldn't touch a lot of this. Because basically what you're doing is you're outputting Ethereum data structures for signing by the orchestrator, correct?
That's right. It shouldn't really. I mean, the Stargate stuff is kind of a pretty dry, like, refactor kind of thing. It's more the merge conflicts we anticipate are probably just due to the fact that you're going to be touching a lot of different files, and so it's just naturally, logically, it doesn't make a huge, like, it's not like confusing, like figuring out what the changes are going to be, but it's just like the fact they're going to be in a lot of stuff.
Yeah.
So,
totally.
yeah. But just continue with the batches. What happens is that the validators put together the Cosmos chain, basically the state machine, the Cosmos chain puts together these transaction batches. And then a relayer is able to take these batches and submit them to Ethereum. And every transaction in a batch has a fee attached. And so they get paid those fees. But of course, they have to pay for the gas to submit it to Ethereum. And then once it's on Ethereum, there's another event that comes back into Cosmos. The validators are watching the chain. They bring an event back in that says, the batch with this nonce has been successfully processed by Ethereum. And it's important to realize also that there's going to be a delay. So we just think about 50 blocks, although we don't know what it will end up being. It's like some adjustable constant. But basically, you have to think about the fact that the Cosmos chain learns about stuff happening in Ethereum like 50 blocks late, basically. And so then what happens is that once a batch comes in, let's say they see that batch nonce 5 has been successfully submitted. Then what happens is that if there's like a pool of all these batches that haven't been submitted yet, and then if a later batch is submitted, the earlier batches are then basically all the transactions are freed. So because the contract won't let you submit a batch with a lower nonce than what's already been submitted, you can say that since a higher nonce has been submitted, the previous ones cannot have been submitted, and those transactions go back into the transaction pool, and then they can be turned back into new batches. And I think, Justin, part of what we need to work on is like how the batches are put together, because that's still a pretty big open question, right, Justin?
Okay, cool. That's very helpful context for sort of the challenges that you guys are facing and where I'm going to run into issues there. But as far as the code that you're writing, Stargate shouldn't mess with it too much. It's just going to be on the transaction side, which is all going to be wrapped in a shitload of interfaces anyway.
Yeah, actually, I do have a question to ask for that. Sorry, Deborah, were you about to say something?
Oh, I was just trying to get a little bit of a clarification on the timelines. I know talked about some of the work to do, and I wasn't sure how that was all going to fit into time pieces.
Theoretically, none of it should take more than, so getting batches working and getting the Stargate upgrade, both of these shouldn't take more than 2, 3, 4 days each. I kind of hope to wrap them both up by the end of this week. And that's why we're talking about merge conflicts so much, because chances are if we're both working on them in parallel, which is the plan, we're going to end up with that sort of situation. I estimate that it may take a few more days into next week, or the week following, since I'll be on vacation, that will to get the orchestrator to send transactions on Stargate. But I think Zaki seems to have a plan. He's been testing some stuff out. He uses the same code, so I think we'll be okay.
Yeah.
I also, for my timing here, I'm going to be probably not working on the project after this week. So I want to get everything done so I feel it's on steady footing. And so there's a bunch of little cleanup stuff and security stuff that I kind of wanted to do. So we should probably figure out, Justin, like how much I can work on that while you do batches and check the Stargate. And it's another merge thing, of course. But there's stuff like uint 64s are being used. We need to use SDK.ints.
For big ends.
Because otherwise there's a big mismatch between the Ethereum integer size and, so there's some terminology stuff, like the relayer and ETH signer versus orchestrator. And there's a lot of to-dos in the code where the to-dos, basically, I've been using them just to say that something needs a little bit more review. And so I want to kind of make a list of that and go over that kind of stuff. Definitely something else too. This is after Stargate though. There's the denominations on the Cosmos side consist right now of I believe it's the word Peggy and then a hash of the address of the token that is being used. And after Stargate, we're not going to have that 16 character limit anymore, so it needs to be changed to Peggy and then the full string address of the token.
There's would we want to use that? So the way that we deal with this in IBC is it's like IBC hash of thing, and we can have arbitrarily long denominations on there. That might be something, it's called the denomination trace thing.
How does that work? Like, is the 16 character limit going away, or what's going on with that?
No, the character limit doesn't go away. The way that we've gotten around the character limit is what we're doing is we're storing like prefix hash in state, and then there's a lookup table for the hashes to the actual human readable denominations.
Oh, I didn't realize that. So there's no, you protect against collisions because you protect against collisions because you enforce that there can only be one.
Yes.
That's tough. I mean, that's like, I mean, I don't know, like, if you could look up, maybe, I mean, somebody would have to calculate what the cryptographic hardness of this is, but the issue I would see with that is that basically, so Peggy, the way we've been assuming to do it is that we just take the address, the contract address of the token that's being used, and that's what we use as this identifier. And if you hash that into a shorter hash, that's actually, I think it's about technically the same thing as just truncating it. But if you hash it into a shorter hash, then
what it is a hash of the metadata. So we can store the contract address, the ERC20 name, and a couple of other pieces of data in this metadata struct. All of that gets hashed to have the representation that lives on chain. What I've done in the relayer with these is disambiguate them on the user interface side. So users are never exposed to these hashes. What they see is nice human readable denoms.
Oh, no, I agree with that for sure. That's so much nicer to see the symbol as well. But
this is something, and like this is going to come in with Stargate. So like we can make this a to-do for me like next week or the following week to kind of like look at integrating the Peggy denoms into this denom system, into the denom metadata stuff. This is just going to be a really nice to have for explorers and wallets, and a lot of the issues that we're running into with denoms and IBC around multi-hop transactions and how to like surface that information to users, we're not going to run into on Peggy since it's just this two-way bridge. So we can make a lot of like better assumptions around asset naming that are going to make this easy. But that coin metadata service should solve most of those issues for us.
And I didn't realize there was a metadata service.
Yeah.
Well, I was wanting to say that the reason I'm concerned about the denominator is that I'm not like not from the UX perspective, although it's really important, but from a security perspective. So I don't know how long the hash is going to end up being, but if it's shorter than an Ethereum address, then potentially it would be easier to mine for collisions in that hash than it would be to mine for collisions, obviously, in an Ethereum contract address. But if it's still sufficiently hard that it would be impossible for somebody to find a collision in that denom hash, then obviously it's not a concern. But that was my thing. I was like, let's not truncate the address because it's lowering the security, but if we establish that it's not a concern, then it's okay.
How many characters is that?
So, I mean, obviously for Peggy, we should try and be compatible. Anyways, they should look like one-hop IBC coins, essentially, so that wallets are compatible and we can lean on all this IBC wallet work. And then,
hey, Jack, is that hash there? Is that that's the hash?
Yeah.
That looks really long. That looks like way longer than 16 characters. That's definitely long enough for an Ethereum address. So
64 characters.
What was it?
It's a 64 character hash prefix.
Well, I would still say that we should have the prefix, and then we should have the full Ethereum address. I guess I don't have an opinion on whether it's hashed or not. It seems like it'd be simpler to put it in as a string, but I just didn't want it to be reduced in length.
Yeah, the reason it's hashed is because we can store additional pieces of metadata in there. And if we want to store the ERC20 token name along with additional metadata that we can get out of the contract, this hash stores all of that and allows us to disambiguate it within Peggy to allow for really nice UI. So, this is like, really it sounds really what?
It sounds really rad. That sounds cool.
Yeah. It's nice. It is a little complicated and it's not the best, but we'll get it integrated. And this is like a after Stargate thing. So hopefully that helps.
Cool. I think as long as we can stick to whatever standard Stargate is popularizing and maintain the security we need, then we're good. We should just try and break them as little as possible so that things show up right. because we will have the inevitable weird situation of somebody IBCing a Peggy Bridge token like 6 chains deep, and then you're going to have to wonder what the hell are we doing with naming this thing now. Um, so, yeah, I think that covers that. Oh, Jahan, we discussed the denom issue, right? For IBC tokens, because they can have different digits of precision. We decided that wasn't an issue so long as you convert them correctly.
Yeah, that's going to be another thing that needs to be figured out for the UX. I mean, Ethereum tokens have one of the pieces of metadata is the number of decimal places they're going to have. And so that's the kind of thing that you would want to have surfaced on the Cosmos side as well. So you show the right number of tokens in people's wallets. You don't have, if you send one die across, you want it to be one die and not like, 1 trillion die. Yeah.
1 trillion die, 1/1 trillionth of a die, etc., etc.
This is the exact use case that we designed the Bitcoin metadata service for. So
Okay, it sounds like
Nice.
we are. Yeah, so it sounds like we're doing things in the right order, doing the Stargate upgrade
We
now.
probably shouldn't get bogged down with
I agree.
probably shouldn't get bogged down with this denom stuff, but I just want to mention one more thing, which is that if
Yeah.
you're talking about the symbol, and even the number of decimal places that's supposed to be used and stuff like that, all those things in the Ethereum project can be changed. And we had a vulnerability that I found the way we were doing that, where we're currently doing the denoms, where if somebody went in and changed somebody who had an Ethereum contract, token contract, which would change its metadata, and that was being brought into the Cosmos denom, then Peggy, the way it was set up, would view that as being like a different token. And I'm not sure what kind of mischief could be done with that, but we don't want that to happen. So that was another concern with the denom, is that you really just want to have it. You can have the metadata in there for UX, but you really want to have it keyed. Like, no one's actually going to change the symbol, but you want to have it keyed off of like only the address, because that's really the only thing that can't change on a token contract. So that's to think about as well. But yeah.
okay, cool, good to know. And as we're working with that service, we'll make sure that those security concerns are addressed.
Okay, cool. So we're coming up on 30 minutes. I don't think we have anything else to really address other than to get to work. Unless you have some questions, Jack. If you want us to go over code, we can. Or we can do it in a different context.
I'll
We just need some time
I'll
to
be
look at stuff first.
I'll be getting my hands wet today. So
Okay, you're sure to have questions, just not quite yet. That's good.
I mean, there's a lot more stuff we could review. I don't know if this may not be the venue, because we don't want to use everyone's time. But
You know, I have questions. I drop in like hey, I got a question. A bunch of code, and then there's going to be some stupid answer that you can give me in one sentence. So looking forward to some of those exchanges later.
Yeah, well, there's lots of detail. So, fortunately or unfortunately, that's pretty much what remains for Peggy at this point. We have the design. I think the only major logic is the batch generation and is like batch management on the Cosmos module side, like when to make, when to renew, when to mint and burn. The details of that logic need review. We fixed the details of the Oracle logic pretty well, Jahan. Is there any flaws that you can remember? I think we need to do like an outgoing review of that, and that's minting.
yeah,
And then
I'm happy
burning
with
is
it.
to be done.
There's stuff like there's some to-dos in there I have around stuff like, there's a place where I'm using a lot of different integers of different kinds, unfortunately, because of what the Cosmos SDK exposes to us, which I would just want somebody to take another look at it to make sure I'm not going to run into overflows or something. There's a bunch of little stuff, but it's pretty much done. It just needs a review. There's the bootstrapping.
The bootstrapping question.
Yeah, we have an issue on that too. And we used to have a really complicated bootstrapping thing where it was all automatic and it would look at like the code hash, the contract, and all kinds of stuff like that. But then we established that, it would also just be possible for whoever is coordinating the upgrade of a Cosmos chain to Peggy to simply give everybody the address of a contract, all the validators, and they just all put it in. And if it needs to be checked that it's the right code hash, the validators can do that themselves when they're putting it in. And it's way simpler and easier. So we don't really need to implement anything for that.
No, we don't really need to. There's the potential for strange issues where in highly contentious situations where people disagree on what the valid bridge is, and the point of a bootstrapping procedure would be that you would make a unambiguous way to achieve consensus of that on chain. But this is also actually a fairly complicated process, and the reality of the matter is, we don't expect the like high contention case to be a problem because somebody's going to deploy it. Everybody's going to check the code hash, and they're going to be like, okay. And then, if you really want to, you can even do a governance vote on it. It's just not. It's just that our code, the like actual Peggy module, does not read the output of a specific governance vote on these values. It just expects people to achieve external consensus on them.
I think that's fine.
I think it's fine. It's more
the
than
only
workable.
difference. The only difference I could see is if you use the code hash and have everyone synchronize like automatically around what the exact contract address is that implements that code hash. The benefit there is that you don't have to have a ceremony, but that's really the only benefit. And it's like more of a nice to have than a need to have. So
yeah. Okay. I think we've covered everything we want to cover. So. Yeah, thanks, Rodrigo.
Thanks.
And thank you, everybody, for showing up. And we will see you all in 2 weeks, or if you feel like dropping by any of the multiple Peggy channels just to ask questions, you can do that at any time. So, bye, everyone.
See everyone on the interwebs.